Hi, I'm Ms. Fung. Today we're going to look at vertical translations of sine and cos graphs. So we're going to be talking about moving up and down. So for example, when we did parabolas, x squared plus 3, so the value outside x plus 3 will move it up by 3. X squared minus 5 will make the parabola move down by 5. So similarly, we can do it for sine and cos, where we add or subtract a value. And we call this a vertical translation. So let's have a look at what it actually looks like. So here we have y equals cos x minus 1. Let's draw the original graph of y equals cos x, where it starts at 1 and it repeats at 2 pi, so it ends up at 1 again, and etc. So what happens when we do minus 1? Minus 1 means we're moving the whole graph by 1 down. But how do we sketch that by hand? So what we do is we sketch what we know, so the original graph, and then we move each of the points down by 1 and just the y value. So for example, the point 0, 1 would be now 0, 1 minus 1, which is 0, 0. The point pi on 2, 0 will be now pi on 2, 0 minus 1, which is pi on 2 and negative 1. So the y value changes. So minus 1 becomes minus 2, the 0 over there becomes minus 1, the 1 over there becomes 0. So I'm subtracting 1 from the y values. Now we have all these dots, we just join them all together to get the graph. Let's see another one. What about a sine graph of sine x plus 2? So again, we sketch the original graph, which is between 1 and 1 and has a period of 2 pi. See, the scaling will affect the way your graph looks. So just scale so they fit on your page nicely. So adding 2 would mean each of these points I add 2. So the y0, 0, 0 will be 0, 2 up here. And then we put a dot there. So the point pi on 2, 1 will end up at pi on 2. 1 plus 2 is 3. The point pi 0 will be, adding 2 will be pi 2 up here. The point 3 pi on 2 and negative 1. Negative 1 plus 2 is 1. Negative 1 plus 2 is 1. And we etc. etc. So the graph has been moved up by 2. Let's do an example. Sketch y equals 3 sine 2x plus 4. So what does the 3 tell us? It is the amplitude of 3. And now, usually the range is between 3 and minus 3, but we also have a translation. So let's do the other values first before we do the range. So the period is 2 pi on 2, which is pi, and the 4 is a translation of 4 up, or in the vertical direction. So now that we know everything's moved up, the range is going to be, it was 3 and minus 3, but it's now 3 plus 4 and minus 3 plus 4. So the range was minus 3 to 3, but now we have to add 4 because the whole graph has moved up. So now the range is minus 3 plus 4 is 1 and 3 plus 4 is 7, between 1 and 7. So again, I always like to sketch really lightly or even just dot the original graph without the translation and then add the translation after. So the original graph without the translation would have an amplitude of 3. It's sine, so it starts at 0, 0 and it goes to 0 again after a period, which is pi, etc. So now to translate everything up, we take each of these points and we move it up by 4. So we know that the range is 7, so the highest point will be 7, the lowest point will be 1. Halfway of 1 and 7 is 1 plus 7 is 8 divided by 2 is 4. So all these x-intercepts will be on the 4 line. So let's move these dots. So that dot will be at 4. That dot there, that point there, 3 plus 4 is going to be at 7. That point there, the x-intercept 0 is going to add 4 will be at 4. That point there, minus 3 plus 4 will be at 1. That point there at 0 plus 4 will be at 4. Now we sketch. Example 2, sketch y equals root 2 sine x minus 1 between 0 and 2 pi. We know that root 2 is roughly 1.4, and it's good because we need to know that when we're sketching, so we roughly know where to put our values or our points. So root 2 gives us the amplitude, and the period is just 2 pi because there's no value in front of x, and the minus 1 gives us a translation of down in the vertical direction. So the amplitude is root 2, which means our lowest value is minus root 2 normally, and our highest value normally is root 2. But because of the translation, our lowest value is negative root 2 minus 1, and our highest value is root 2 minus 1. And if you put that in a calculator, that's roughly negative 2.4 and 0.4. It's always good to have a rough idea of how much it is so that you can sketch it properly. So we start with our original graph without the translation first. So root 2 and negative root 2, period of 2 pi. So halfway is pi, and it's a sine graph, so it starts here, goes through there, and ends up there. Now moving it down, we're going to put all these values in, so it's going to get a little bit tricky, so be patient with me. So we're going to put in root 2 minus 1, which is, well, root 2 is 1.4 minus 1 would be about a third of the way, so here. And then our lowest point will be negative root 2 minus 1. So the same distance you go down, you should have over there, so your graph is consistent. And halfway, these two values, or if we move 0, 0 down, we're going to move it down by negative 1, so there. So now we put in all our dots, so that 0 value is going to go down to here, negative 1. That dot at that point at root 2 is going to be root 2 minus 1. That point at 0 again is going to be at negative 1. I'm just reading the y values, so it's faster. The point over there at negative root 2 is going to be negative 2 minus 1, and that point at 0 is going to be minus 1. So we've moved them all by minus 1. So sketch that in. And now we notice that they are x-intercept. In the previous example, we had no x-intercept, and that's because, let me bring it back for you. In the previous example, our graph wasn't touching the x-axis, but this time our graph does touch the x-axis. So we have to figure out what the x-intercepts are. How do we do that? We let the whole equation equal to 0. So now we have root 2 sine x minus 1 equals 0. Bring the 1 to the other side. Now divide both sides by root 2. And now when is sine x equals 1 over root 2? That is at pi on. So this is where you need to know your triangle. So it's pi on 4, and it is positive at the first quadrant or station 2 Caulfield, and the second quadrant. So the first and second quadrant, or in other words, it is pi on 4, and the second quadrant would be pi minus pi on 4, which is pi on 4, and 1 minus a quarter is 3/4. And let's check. That looks like that's pi, halfway that's half. That's half of that is a quarter, and 1/4, 2/4, 3/4. So we know we're correct when our scaling fits well. Example 3, sketch y equals 4 cos 2 x minus pi on 3 minus 2 between 0 and 2 pi. So what are the values telling us? Well, the 4 is our amplitude, and the 2 gives us 2 pi on 2. The period is just pi. And the minus pi on 3 and the minus 2 means we're moving down by 2 and to the right by pi on 3. So let's have a look at the amplitude before we sketch. 4 means we're going up 4 and minus 4, but because we are translating up and down, we have to, we're translating 2 down, we have to subtract 2 from those values. So it'll be minus 4 minus 2 and 4 minus 2. So our range will be between our range is minus 6 and 2. Let's work out the x-intercept first. Let's do all the ugly things first, the difficult part. So x-intercept is when the whole equation equals to 0. So when we have that, we can see that the first thing you can do is move the 2 to the outside. The second thing you can do is dividing both sides by 4. 2 over 4 is a half. And now we see that there's a cos of this chunk is equal to a half. Now we have this whole chunk, and the domain is our original domain for x. So what is the domain for this whole chunk while we're working it out? Well, the domain for the whole chunk is putting the whole chunk where x is and the left and the right of that domain. So wherever we see x, we substitute in 0. So see, 0 minus pi on 3 times 2, that's minus 2 pi on 3. And wherever we see x, we put 2 pi for the right side. So 2 pi minus pi on 3, 2 minus a third, 6 minus 1 is 5/3 times 2 is 10/3. So 10 pi on 3. So now we have the domain of this chunk while we work it out. And then we can, while we work it out, we also have to figure out what cos of what is a half. And that we need to know our triangles. Cos of what is 1/2? That's cos of pi on 3. And since it's positive, which quadrant are we working in? We're working for cos is positive in the first and in the last quadrant. So with all this information, let's find our values. What are our values going to be? So let's get a bit of space. So between minus 2 pi on 3 and 10 pi on 3, what do we have? So first of all, we have to start in the negative direction. So we can go down by negative pi on 3. That's our first solution. That's inside the domain. Can we go further? If we go further, we will be past minus 2 pi on 3, so we can't. So next, let's go into the positive direction. So going up, that's pi on 3. That's also an easy one. And then in the fourth quadrant, so we go all the way around now, that is 2 pi minus pi on 3. And we look at the domain, 10 pi on 3 is almost 3, so that's within the domain. And let's do the next one. If we keep going around, that's 2 pi plus pi on 3. Is that inside the domain? Let's have a look. So let's simplify. So minus pi on 3, pi on 3, 2 minus 1/3 is 6 minus 1 is 5 pi on 3, and 2 plus 1/3 is 6 plus 1 is 7 pi on 3. 7 pi on 3 is inside the domain, so that one's okay. So do we need to keep going further? That's the other question you should be asking. Well, if I go further, that means I go from here all the way there. So that's another almost 2 pi. So that's way too far. You can try it and see if the number is too big compared to that. But we can clearly see that it is. If you're not convinced, do try it if you're not good with fractions. So do we have the x-intercept now? No, we have to work it out by solving for x. So first, get rid of the 2 by dividing both sides by 2. So dividing by 2 is easy. You just multiply the denominator by 2. So we have minus pi on 6, then pi on 6, 5 pi on 6, 7 pi on 6. Next, we have to add pi on 3 to the other side, but adding thirds to sixths, it's tricky. So what we're going to do is we can convert this. Instead of x minus pi on 3, we can rewrite this as x minus 2 pi on 6. 2 pi on 6 is the same as pi on 3. 2/6 is the same as 1/3. Now, to add this to the other side will be much easier. So let's add 2/6 to each of these. So minus 1/6 plus 2/6 is, minus 1 plus 2 is 1/6. So pi on 6. 1/6 plus 2/6 is 3/6. So 3 pi on 6. 5/6. 5/6 plus 2/6 is 7/6. And 7/6 plus 2/6 is 9/6. Then we simplify. So x is equal to pi on 6, 3/6 is a half, 7/6, and 9/6 is 3/2. And we just double check that the last value, 3/2, is inside our domain of 2 pi. Yes, 1.5 is inside 2 pi. So now that we have all the information, let's sketch. I've already done the axes and you can work it out by yourself slowly, but I've started with the domain, 2 pi, and then I've chopped it in half because I know the period is pi, and then I've chopped it in half again because I know that the graph will, the intersects will go through the middle. Sorry, I need the middle of that to sketch the graphs, but I've also find the lowest common denominator and I chop my axes that way. How did I do my y-axis? Well, the amplitude is 4, so my original graph starts at 4 and ends at -4. And then I move each of these values down by 2. So the 4 went down to 2, the -4 went down by -6, and my 0 went down to -2. That's how I got all these values. Next, let's sketch our original graph without the translations. So the original graph without the translation. So it starts at 4, sorry, cos. So it starts at 4, ends at 4 after one period, which is pi up here. So it goes like that. Next, we do horizontal or vertical translation. I like the horizontal translation. Oh, I've accidentally deleted it by pasting the x-intercept on top. But there is a horizontal translation of pi on 3 to the right. So we move each of these points to the right by a third. So this is how handy it is by having this into thirds. So a third is, so that's pi, a third is 2 of these dashed lines. So that dot there will move 2 dashed lines. That x-intercept will move 2 dashed lines, so 1, 2 over here. And that there will move 2 dashed lines over there. That one will do the same, and that over there will do the same, etc. So the translated graph will look something like this. Now we're moving the graph down as well. So let's move each of these new dots down by 2. So that will be there. That dot will move down there. That dot on -4 will move to -6. That 0 will be -2. And that 4 will be a 2. And then let's sketch our graph now. So this is our actual graph. And we have to continue the graph to the left side. And we need to get rid of anything that's past pi and 2 pi, sorry, because that's our domain. So now we put in our x-intercept. So here we have the first one is pi and 6, and it looks pretty good because it is a 6 away from there. See, you can count the dashes. The next one is pi and 2, and yes, we went through pi and 2, so that's fantastic. The next one is 7 pi and 6, so it must be that one there. And the next one is 3 pi and 2, and our graph does go through there. Let's clean it up a bit. So that's what our final graph should look like. Thank you for watching, and I know it's a bit tricky, and I'll see you next time. Bye!